Let's be honest, LLMs are amazing at generating text, but they can't really do anything beyond that. For example, they cannot read your files, they cannot do math operations, they cannot reliably convert units from, let's say, Celsius to Fahrenheit. But what if we could give tools to the LLMs so that they can call those tools whenever necessary to provide accurate and reliable responses? That's exactly where Model Context Protocol or MCP servers come in. Simply put, that's a standard way to develop and give tools to the LLMs and instantly turn those LLMs into agents. In this video, I'm going to show you how to develop your tools as MCP servers so that you can instantly transform your LLMs into reliable agents. So without further ado, let's start. Okay, so in this video, we're gonna develop an MCP server for unit conversion. Imagine like we wanna convert some amount of kilograms into pounds or some degrees of Celsius into Fahrenheit. And by the way, if you want a more detailed introduction to MCP, I have a dedicated video for that. First of all, let me give you a big picture understanding of what we're gonna do. Developing an MCP server is really simple. We're gonna develop the tool in regular Pythonic way, and then we will decorate our tools with a simple decorator provided by Fast MCP library. So let me show you. For a standard way of developing our MCP server, I strongly suggest that you build your project with UV. And if you're not familiar with UV, don't panic. It's really simple and easy. You just need to give it a try. UV is a Python package manager and project manager developed in Rust, and it's really fast and efficient. So if you don't have it installed, you can easily install it with pip install UV command. Like, let me show you. You can easily install it like this, pip install UV, and you're done. And once you have it installed, and once you're in your project folder, you can easily execute UV init. And as you see, as soon as I execute this command, it will generate a bunch of files, bunch of really necessary files. It pre-populates our .gitignore files with some usual folders for when we want to build and publish our project. And it creates a .python version to specify what Python version we're gonna build this project on. And it will create a simple main file, a pyproject.toml, in which you can see the name of the project, our versioning, the description, where is the README file, and what Python package do we require, and also the dependencies or the libraries that we need for this project. It has also created a blank README file. So we're gonna build our MCP server here. First of all, I need to define the tools in regular Pythonic way. So let's say I want to have a separate function to convert from kilograms to pounds. So def kilogram, or let's say convert kilogram to pounds, and it gets a kilogram amount, and it returns kilogram times this constant. And similarly, I want to do the reverse, so a convert pounds to kilogram, and this will be the function body. And well, since this is an illustration video for how to develop MCP servers, I'm not gonna spend a lot of time to make a perfect conversion package, but let's just add two other tools for temperature conversion. Let's say I want to convert from Celsius to Fahrenheit, and also I want to convert the reverse from Fahrenheit to Celsius. And that's it. This is enough. So we have defined 4 tools to convert from some units to some other units. And now we're gonna make these tools usable by LLM agents. And that's where MCP comes in. So if we wanted to do this without MCP, one way was to just include the signature, the name of the functions, their arguments, their return types, and their descriptions inside our prompts, and then tell the LLM that whenever you need to call this tool or these tools, you need to come up with this specific pattern, like for example, call with all capital letters or some similar expression, and then the function name and then the argument, something like that, or a JSON to do this. And then we would have needed to post-process the LLM's response to see whether it has called the tools or not. And if there wasn't the expression for tool calling, we should have fetched or extracted the arguments, the function name, and do it ourselves and then return the result. But if you want to do it that way, first of all, it's so error prone. There is a high chance that I make a mistake in my prompt, or my prompt isn't that appropriate or that high quality for the LLM, or even it's a tedious task. We should do this every time we want to include a tool. So that's where MCP shines. They've defined a standardized way to develop a tool and hand it easily to the LLMs or agents. So simply put, we could have done this even without MCP, but MCP provides a standardized way, a standard protocol to develop tools. And by the way, giants such as OpenAI or Claude or other LLM providers, they will train their models, their LLMs, on MCP standard, on this protocol, so that the LLMs will be well trained on MCP types of tools and function callings. So we currently have pure Pythonic tools or functions. Now we want to parse them into MCP standard. In order to do so, I just need to use the Fast MCP class defined in MCP module. So I need to add it to my project. And since we're working with UE, we'll use UE add. This is just like pip install. So we'll say UE add. I want the MCP with its command line interface. Done. And if we now take a look at PyProject, you see that it has been added to our dependencies. Now we have MCP command line interface. Okay, so now I can import the Fast MCP class. So from mcp.server. I don't remember if it was servers or server, but let me change my interpreter to this UE environment to make sure. So if you're working on Mac, press Command, Shift, and P, or if you're working on Windows, Control, Shift, and P, and type selected interpreter or choose Python interpreter. And now we can just say, use this interpreter in my project. Okay, you see, now it can give me auto completions. Okay, from mcp.server.fastmcp, import fastmcp. Now I can easily create an object. MCP will be a fastmcp object. I can give it a name. So the name will be unit conversion. And I can also provide some instructions, or you can take a look at the documentation for FastMCP. But this is enough. And now if I want to turn each of these tools into an MCP standard tool, I can just decorate them with mcp.tool. And I can also provide names, titles, descriptions, but if you leave them to the default values, it will pick the function's name and function's type hints and docstring. So it's really important to provide appropriate type hints and docstrings for your tools that you're developing with MCP. So for example, this kilogram, I need to specify it's going to be a float, and the function will also return a float. And I would also include a docstring. So this will be a tool to convert kilograms to pounds. And then let me also specify the arguments, kilogram, float, and the return type, which will be weight in pounds. Okay. Now I can do the similar thing with the rest of the tools. This is for convert pounds to kilograms, and this is for convert Celsius to Fahrenheit, and the reverse. And you see, GitHub Copilot is really good at suggesting these kinds of auto-completions. So now I have my tools, and I also need to decorate these with MCP tool as well. MCP.tool for this one as well. We'll decorate it with MCP.tool, and also for this one. And by the way, if you don't know what a decorator in Python is, I strongly encourage you to go ahead and search online and read about decorators. I may also record a separate video for diving deeper into decorators and what is happening behind the scene with this Fast MCP class. I'm not sure about it. If you like that video, please go ahead and tell me your opinion in the comments. Okay, so we've developed our tools in MCP format, and now I can just run the MCP server. So I can say mcp.run. I can also specify a transport method. It can be stdio, sse, or streamable HTTP, but the default value is stdio. And if you want to just develop a local MCP server and work with it with your Claude desktop or with VS Code, for example, or if you want to develop it for an agent like the ones we have developed in Autogen in previous videos, stdio is more than enough. And one more point about MCP servers with stdio transport is that since they're going to use stdio, it's highly recommended not to do prints in your code, especially for debug purposes. If you want to log something for debug or for providing information for the developer, it's better to use logging package in Python. Okay, now we're done. I said earlier, it's really simple. You see, we developed the tools in pure Python. Then we just imported Fast MCP class. We created an object and decorated each tool with mcp.tool. And that's it. And we just need to run it in the end in our main function. Okay, in order to run this MCP server, what we can do is to use the MCP package we installed earlier. So I can say run. First of all, let's say just run MCP to see a simple documentation of what we can do with MCP. Yes, you see. You can, for example, show the MCP version. You can run an MCP server with the MCP Inspector. We're gonna do that momentarily. This is a simple web application that allows you to inspect an MCP server, make sure the tools, or even if your MCP server has prompts or resources, it will let you inspect them and test them to make sure they work properly before handing them to an agent. You can directly run your MCP server or even install it in Claude Desktop. Okay, so I would say run mcp dev, and my project, my main file is main.py. Starting MCP Inspector, and we need to copy this token as well. This allows us to connect to our MCP server inside the MCP Inspector app. It automatically opens your browser with the Inspector app. Okay, this is the Inspector app, and we need to paste our session token inside configuration. And now I can connect to my MCP server. Okay, Now we're connected. As you see, we have several tabs. Since we just have tools in this MCP server, we're gonna head to Tools tab. I can list the tools. You see, these are our 4 tools. And for any of them, for example, I can give it a try, Celsius to Fahrenheit. And I wanna see what degree of Fahrenheit is 27 Celsius. And this is also the description we've provided. You see, this is the exact doc string we had here. You see, convert Celsius to Fahrenheit. And now I can run the tool. You see, it was successful and it returned 80.6. So this shows that we have successfully developed an MCP server, and now we can easily use this MCP server for our AI agents. Okay, now as the last step, I'm gonna show you how to give your MCP tool to VS Code GitHub Copilot. So in order to do so, you can easily go to Add MCP servers in your VS Code. You can press Command-Shift-P or Control-Shift-P and just type in add server. You see, we have MCP add server. Then it asks us what kind of MCP server do you have? What is the transport type? So it will be a command line, a stdio type. And what command should we use to run the MCP server? So this would be the exact command that you need to execute even in your terminal to run your MCP server. So I can say uv run, and I can provide the project path so that it uses the virtual environment that UV has built for my project. So just in order to copy my path, let's say echo present working directory. This is my path. And the file will be main.py. And what we're going to name it, so we're going to name it, let's say MH, that's my initial the initials for my first name, unit conversion. And do I want it to be globally available so that in other projects as well I can use this, or just in this workspace in this project? So I want to just have it as an MCP tool in this project. I don't want it to be globally available. So you see, as soon as I press enter, we have it in our mcp.json file, which lives in .vs Code folder of my project. And you see, we have the name, the type, the command we need, and the arguments for that command. So now if I go to Grok, for example, my LLM is Grok, or I can use any other LLM as well. And you should be in agent mode. And I can, if I click on this icon for add context, and I go to tools, I should be able to find my tools. You see, there are lots of built-in tools, but yeah, there they are. We have Celsius to Fahrenheit, convert kilogram to pounds, convert pounds to kilogram, and Fahrenheit to Celsius. And I forgot to name them consistently. It was better to also include convert Celsius to Fahrenheit. But anyway, it's fine. And also convert Fahrenheit to Celsius. So I can specifically ask it to use each of these single tools or all of them inside this MCP server. If I click on that, you see it will be here. Even if I don't do it, it should be able to know which tools should it use. So let me first try it with explicitly specifying my MCP server that will be useful for my prompt. This way, I'm actually helping the LLM to select the correct tool. Otherwise, especially in the context that there are many different MCP servers, as you just saw, for example, some especially weaker LLMs might choose the wrong tool to do their task with. So I can say, how many kilograms are 102 pounds. Let's see. You see, optimizing tool selection. And it asks me to allow it to run this convert pounds to kilogram. And it is entering the only argument of this tool, the LBS, as 102. And when I say allow, it runs the tool and tells me, yeah, it's equivalent to 46.27 kilograms. Or if I do this even without explicitly specifying my tools, let's see what happens. What degree of Celsius is 72 degrees of Fahrenheit? Okay, you see, it detected my tools and it asked me to allow it to use this Fahrenheit to Celsius tool, which is the correct one. And now it's telling me that 72 degrees of Fahrenheit equals to 22.2 degrees of Celsius. Okay, so you see, we've developed an MCP server and we've been able to inspect it in the inspector web application of MCP module. And also we've been able to give it to GitHub Copilot's agents. And the process will be almost the same for every other MCP client. I mean, every other application that you're using, such as Claude Desktop or Cursor or other applications. Okay, so now we've developed an MCP server and it's in a decent shape, especially if only we are going to use it in our projects. But if we want to also publish this MCP server so that other developers can also use our developed tool, our MCP server, this is not in the best possible shape. And why is that? If I want to publish this MCP server, I should include in my instructions for every developer that, okay, if you want to use this MCP server, you must clone the whole project. For example, if it's in GitHub, you should use git clone and clone the project. And then you should change this argument in the JSON file to your path of the project, and then it will work. But this is a little bit headache, and also it's error prone. Many developers can do it wrong or can have trouble cloning the GitHub repo, or in more complex project, they may need to build a project, or, there may be problems with this kind of approach. But if you do a quick search on existing MCP servers, there are many great servers that the command is something like this: UEX, run, and just a name. Let's say, for example, MH unit conversion, and end of story. And anyone can just easily copy and paste this JSON into their application, such as Claude Desktop, and it will work. In the next video, I'm going to show you how to develop an MCP server and publish it in a standard way so that anyone can call your tool or can use your MCP server with a simple command like this. They can just easily copy and paste this JSON into their MCP client application, and then they're good to go. So don't forget to watch the next video if you don't know how to do this. I hope you enjoyed this tutorial, and now you should be able to develop your own MCP servers tailored for your own applications. If you enjoyed this video, or you have ideas about MCP servers or applications or tools that are not developed yet or does not exist right now, please go ahead and drop your comments and share your opinion. I hope you enjoyed this video, and until the next one, take care.